This is the notebook hosting our ML model and recommender server. The user and rating data are generated while product dataset was taken from Kaggle. Firstly, we load our required data and perform analysis to check for null or duplicated values. After that, we perform collaborative filtering on product similarity to recommend products based on cosine similarity. Here we can see that the Nike Azure combo set gives us a set of similar products. After that, we did collaborative filtering on user similarity. Here we created a cosine matrix based on the purchase history of the user. Here we take a user SSN as input and get the top recommended products based on similarity. After this, we create our API for login, register, and recommendation and expose the endpoints using ngrok. And this is where our API endpoints are located and running.
So now we will be moving on to our second recommendation system, which is based on a large language model. We have used a variant of the Falcon 70 model in this notebook file. This model uses the bits and bytes configuration libraries to restrict the GPU usage on the Colab notebook and efficiently use it for the further training. In here we load the dataset of our model, which is in the form of a QNA dataset, and the further dependencies are being loaded, such as LangChain and sentence transformers, etc. Now we are using the Falcon 7 sharded BF16 model, and I have specified all the bits and bytes configuration, and rest I have specified the task, which is the casual LM1. Now we are generating the token for our model. Here we have specified the pipeline of the model and the template for the vector embedding. And now on the product catalog, we are generating the product embeddings from the embedding function, and also the for the embedding for the product that we're trying to find. So now I can see for the description for the comfortable shoes, these three items are being generated, the top three recommendation items from the LLM model. And then this is the generation prompt, and then we are mapping our dataset, and these are the different configuration for the LoRa adapter. These are the hyperparameters that we have set for our model, and then those are being passed to the SFTD trainer, and then the training of the model takes place. It takes about 30 minutes to train the model, as I'm running out on it about for 150 iterations. And these are the hyperparameters for the model after the training, and this is the final prompt for our chatbot that we are going to use in our application. And these are some of the random responses that I have generated. And I've tried to simulate a sort of a chatbot on the command line itself, and then I'm using loading my Flask dependencies, and this is the code for the API integration with the application. And lastly, I'm running my application. So now finally, this is the demo of our application, grid card. This is the UI for the login page. We're currently logging in for a customer that we have saved in our database. And this is the and after this, these are the personal recommendations for that specific user. We can see all the products under which, like clothing or different categories. And then we also add a link that takes the user to the Flipkart page for that product, and after that he can check out that product. This is the profile for the user of our application, And now we move on to the chatbot. Now we are trying to simulate a conversation as us as the user, and we're trying to recommend some shoes from the LLM model. And this is the response. Now we have saved an inbuilt keyword, list all product names, to show all the recommended products by the LLM. And these are the clickable links to the Flipkart pages. And rest we try to simulate a feedback response from the LLM. So this was our whole application, and we hope that our solution brings a change to the society.